My talk is titled Shiny, a graphical user interface for the Tidyverse, but don't worry, that title is just clickbait. I'm not going to talk too much about any of those things, or a little bit, but before I proceed, I'm going to apologize that my deck is acting up a little bit. There's a little delay between slides where they both display, so just bear with me a little bit. My name's Carl Ganz. I was told that if I come speak at these events and post memes, I'll get lots of Twitter followers, so my Twitter handle is posted. My day job, I run the technology for a company called Goodtree. If you are under the age of 21, cover your ears. We are a vertically integrated cannabis company based here in SoCal, but also with a presence in Northern California. I'm a grad student at Cal State Northridge, go Matadors. And if any of you see this picture of me and my dog and suddenly feel compelled to adopt a bloodhound, I have a link for the rescue group in the slides. Why another talk about Shiny? So for those of you who maybe attend these sort of events regularly, get into some stats conferences, people love to talk about Shiny because in our little small world of computational statistics, a lot of what we do is really intangible. Writing algorithms, running models, it's hard to really share it with your friends. And so web applications, are something that's very tangible. And so I guess I don't want to be presumptuous. So maybe not everyone here knows what Shiny is. So Shiny is an R package for building web applications. It's pretty much the only commonly used web application framework for R. And so people love to come to these events and show off the cool Shiny apps they've built. And our studio had a little contest recently about Shiny apps that was very popular. And so this is not going to be that. I'm not going to show you any Shiny apps. I'm not going to show you any Shiny code. I'm just going to sort of wax poetic about why I think Shiny is awesome and sort of try to make a claim or argument that part of the success of Shiny sort of parallels and is for the same reasons that the Tidyverse has been very successful. And so before I really get into the nitty-gritty, there's some important vernacular that I really get on the table so that I'm not speaking gibberish. The first word that I'm going to be using repeatedly is abstraction. And so Henry earlier beat me to the punch by using that word in his presentation, but and I'll go into a little bit more detail about it in the next slide. But in essence, abstraction is about taking something complex and reducing it to its essential components. And so R, as a programming language, like any other programming language, it's an interface to the computer. It's a way for us to interact with our machine. And so like all interfaces, whether it be a computer or a graphical user interface like our phone or an audio interface like Siri or Alexa, the purpose of any interface is to make things simple, to reduce complexity as much as possible, but not any more than that. And so I worry that those first 2 points sort of make it sound like programming and interface design is very monolithic, that there's only one way to do things right. And that's not the case. Good abstraction and good interface design requires respect for what your users are trying to do, even if that user is just yourself. And so the last term that is important to have before we proceed is the Tidyverse. So I'm surprised this actually hasn't come up more often in this conference, but Tidyverse is just a collection of R packages that aim to provide an ideal interface for interactive data analysis. As I promised, I would circle back to this abstraction idea. And so the sort of textbook example for abstraction in computer science is this idea of data abstraction and object-oriented programming, that if I have some object and I want to represent it in a computer, what are the essential components I need? So if I'm a mathematician and I want to represent a circle, what are the essential components I need? I'm going to need a number to represent the radius. I'm going to need a number to represent the x-coordinate of the center. I'm going to need a number to represent the y-coordinate of the center. And with those 3 data points, I can unambiguously define any circle in the xy plane in my computer. If I'm a businessman and maybe I'm dealing with personnel records, maybe I need an ID number, a name, and a title, and that will allow me to unambiguously define any object, personnel record in my system. When Henry earlier was talking about features as an abstraction, that was a very meta. It was sort of this idea: if I want to represent a computation in my program, what are the essential components? I need the sort of expression that I'm evaluating. I need a state that tells me the current status of that evaluation, and then I need a value that represents the value once it's evaluated. And so objects are one of the main tools we use in programming to sort of encapsulate abstractions. Another tool we have is functions. And so I have a very basic function that we've all probably interacted with before here, the read.csv function. And so how many people here are prepared to write a CSV parsing algorithm from scratch? Please nobody raise their hand. Okay. For anything that we want to do in the actual CSV parsing algorithm is completely irrelevant. It is not essential. The only component that is meaningful for me to be able to parse a CSV in my program is to specify the path to the file. Certainly, we could have built a simpler interface, and so as I alluded to earlier, it's possible to build interfaces that are too simple. If I wrote the read CSV function that had no file path, it would be ambiguous what file was being read. Maybe it would be a random CSV in the current directory, maybe it would be a random one on my computer. It would be a bad interface because it would be ambiguous. This slide is very important because it really brings home 2 points that I want everyone to take away from my talk. And so nobody actually uses the read.csv function anymore, right? All the cool kids use the readr package. And so before the readr package was very popular, it was very common to get scripts handed over to you that had a function that looked something like this. Read_csv, just a wrapper around the read.csv that replaced the much maligned strings as factors default. And so why does this function have value? Why do we care about this function? Why would we write this function? And so the answer isn't because of what it does. There was already a function for reading CSVs. This isn't adding any new functionality. It's simply providing an interface that is marginally better. And so that's an important takeaway, is that the value of functions are not necessarily what they do. If I say, oh, my function does X, that's not necessarily what the value of your function is. The value of your function comes from, can I make an interface that makes doing X easier than it was before? And so, the other important takeaway I want you to take is that what is the correct abstraction or the correct interface design is context dependent. And so many people often ask the question, why did the authors of R use strings as factors equals true as the default? Were they dumb? Were they silly? Was it an error? And the answer is simply that the world has changed since the 80s or the 90s, or whenever S+, was really invented. When S+ was, when early R was around, strings were very memory intensive and nobody wanted to use them. And so people preferred factors, and read.csv had a logical interface. All these years later, the R community has evolved, and strings are no longer second-class citizens, and factors are not as popular. And so we now prefer a different interface. And so the thing I want you to understand is that nothing about the read.csv function has fundamentally changed. Nothing about its interface has fundamentally changed. It's that the community around R has evolved and made the interface no longer optimal. And so that's what I mean, that proper abstraction and proper interface design is context dependent. You really need to understand what your users are trying to use your function to do to design it correctly. And sometimes that changes over time, what your users are trying to do. And so I always have this image of John Chambers or Richard Becker getting complaints about strings as factors and shaking their head. We didn't know. We didn't know. So just to really bang home this point about abstraction, I'm going to give you a non-example, because sometimes it's easier to see a property when it's not there than when it is there. Because so far a lot of these things I've described to you, it's just a function. If I'm picking some sort of action the computer does and making it simpler to access, that's what functions do, right? But not all functions do that, and so I think this non-example is very helpful. So what does this function do? So there's two parameters. There's an arbitrary function, f, and then an arbitrary list that then gets passed to that function and evaluated. So why is this function worthless? Is it because you cannot do anything with it? No, you can essentially do anything with this function, or everything with this function. You could pass read.csv as the function and the file path as the parameters. You could pass lm as the function and run a linear regression. You could pass a machine learning algorithm in there. It's flexible, it's dynamic, it's amazing. It's quite a function. So then why is it worthless? Well, because every single thing it does has to be explicitly specified by the user. There is no abstraction. It is a terrible interface. And so to go back to that earlier slide about where is the marginal value of this function, it's in the improvement of the interface and not in what it actually does. Like similarly, like the worthlessness of this function is not in its absence of functionality, but in its absence of abstraction and in its terrible interface. So at this point, since I promised to make this a little bit about the Tidyverse, I figure it's worth mentioning dplyr because it's a really nice example of how abstraction and interface design can make all of our lives very easy. And so dplyr is a domain-specific language for data manipulation. And so what that abstraction has done is said, what are the essential components of data manipulation? And by thinking hard about this and building an interface that really minimizes complexity, we're able to get two really big benefits, which are also benefits that we get from the futures package and the abstraction there. And one of them is that you're able to decouple the interface from the actual implementation. So with dplyr, instead of writing code that directly manipulates our data frames or our objects, I write code that describes to dplyr how I want data manipulations to be performed, and then dplyr selects the correct implementation depending on whether I'm passing a R object or a SQL object or a Spark object to it. Similarly with as Henrik was showing earlier, that he found an interface that reduced the complexity of futures and reduced it to these essential components. What the user has to specify where things are computed. The programmer specifies what is computed asynchronously or in parallel, and then that is decoupled from the actual implementation. So like, having the interface that's simple makes the implementation separate, and that allows for all sorts of different implementations. The other benefit is accessibility. So one of the things we've seen with dplyr is that even though it is our code, it's accessible to people who don't necessarily know how to read our code. Otherwise, it's almost like plain English. And as a result, we've often seen in other countries people have rewritten dplyr using verbs in their native tongue. So because it's so human readable that you almost need to speak the native language to understand the code. And so the real accomplishment there is now we've taken something that was very esoteric, this sort of manipulating data in SQL tables, manipulating data in Spark tables, manipulating data in our data frames, and we've made it accessible to literally anyone who can read, select, mutate. It's very simple. And so this sort of phenomenon of building increasingly simpler interfaces appears so often in computing that I've decided to name it the tree of descending complexity. And so, as I joked in the earlier slide, if statistical computing required us to work with, stamping card codes and working with assembly and writing code that worked on the hardware directly, very few of us would be working in computational statistics. It would be a very esoteric field. And so, back in the days, all computing was very esoteric for this reason. People used to buy computers, they'd have an Intel 830 processor, and then 2 years later they'd buy a computer with an Intel 835 processor, and none of the code would work, and they'd have to rewrite everything. And then, years later, we were able to write code that sort of abstracted the actual computations from the hardware, and so we could write code that was portable on my computer, worked on your computer. And then many years later, we were able to take C, that language, and build R with it. And so now I can do computational statistics without having to worry about compiling programs or being really strict about data structures or working with memory directly. And so at each of these steps, we're taking something that's complex, reducing it to its essential components for a wider audience, and making that tool accessible to more people. And so certainly the Tidyverse is sort of that next step. And R was very popular, but it was not necessarily as accessible as it could be. The interfaces weren't as consistent. And so there was a lot of effort into making a very consistent interface built on top of R so that it was accessible to an even larger audience. So people didn't have to be computational statisticians just to read and understand data manipulation, to work with databases, to work with Spark. And so I wrote this little tree here, assembly to C to R to Tidyverse to Shiny, because Shiny apps are the sort of graphical user interface on top of R and Shiny that makes all of that underlying functionality accessible to anyone who has a browser. If there's an R package, if there's some R package that does a really cool machine learning algorithm, that's not going to be accessible to a non-programmer because they're not going to be able to open R and get that machine learning algorithm run. But if I can build an interface where they can upload their data set, select the algorithm, run it, suddenly that whole tool set is available to a new audience. And certainly, graphical user interfaces aren't the end-all be-all. I joke about the Siri Alexa here because there are audio interfaces. There are all sorts of different types of interfaces. I remember at JSM, maybe it was 2 years ago or 3 years ago, Yihui gave a talk about Shiny, and he had connected his Shiny app to a voice recognition software, so he could go up to the computer and say, "Plot empty cars," and then the plot would appear on the screen. And people at JSM literally gasped. It was shocking because it was something that seemed very complex on a new interface that no one had seen before, and that gets people really excited. And that's why Shiny has been very successful, is because it's taking this whole library of tools that our programmers have been spending decades building and suddenly made it accessible to people who didn't even know how to program. And certainly there are microcosms for this phenomena all over the place. Who here has used the Stringer package? So the Stringer package is a wrapper for the Stringy package. It's an interface. The Stringy package is an interface for a C library for manipulating strings high level. That high-level C library is a wrapper for low-level C-level string manipulation. And so there are these many different levels of interfaces with different levels of complexity that we can choose to use depending on our use case. And so many of you are probably wondering, when am I going to talk about Shiny? Because that was like the main thing of my title. And so my thesis a little bit, or actually before I get into that, what is Shiny again? So it's a web framework for R. And so the real achievement has been that it's taken sort of the complex web development process and made it accessible to data scientists who wouldn't otherwise be able to build web applications. And then those web applications themselves abstract the sort of challenge of the console and programming itself and make all those tools available to non-programmers. And so Shiny's popularity is built upon two fundamental abstractions. Shiny makes building the front end and the back end of a web application and then hosting that application so simple. Many people, such as myself, think they are now DevOps and web engineers. You're not. The other and more interesting side is that the Shiny applications themselves abstract away the programming portion of the Tidyverse interface, and that they sort of reveal that underlying functionality to a much wider audience. And so, as I sort of said, I'm not going to really show you any actual Shiny apps. This is just like a really silly toy example. But the important takeaway is that you can, if you've worked with Shiny before, it's like really immediately obvious that this is a Shiny app because the Shiny applications have a very, if you use them off the shelf with the regular defaults, they have a very standard layout, and it's sort of consistent with how we think about functions in the Tidyverse. There's this little sidebar with parameters, and you sort of want those parameters to be some sort of minimal spanning set that covers all of the functionality you want to just offer to your user based on their use case. So again, what those parameters are context dependent. You don't want to make it too complex and offer too many parameters so that your users get lost, but you also want to give them enough functionality to get the value out of it that their use case requires. So, it's a similar process of building functions that are consistent with the Tidyverse API and building Shiny applications that are accessible to a wide audience. It sort of has this parallel of finding the minimal required parameters and then doing the work and displaying the output. So just some like trivial examples of like nice things you could do with a Shiny app that maybe you should give a try is, it's all about making things accessible. So R is a glue language. When it was invented at Bell Labs, it was gluing together C scripts and Fortran scripts so that they could be used interactively. Decades later, we're using it for to make C++ and JavaScript play nicely with each other. It's a glue language. And so, since we have all these tools in R for gluing things together, whether it be disparate data sets or different data sources, we have all sorts of tools that we can then provide to a graphical user user to do the same thing. So the example that I like to give is make a SQL database accessible. So I used to work here at UCLA. We had at the School of Public Health, we had a lot of Excel users, and at one point we decided to transition all of our data into SQL databases. And so that's, that seems like an obvious thing to do. SQL is like the good place to keep your data. That's what it's designed for. But we discovered many challenges, that there were lots of stakeholders who were only used to interacting with their data in Excel. They wanted to be able to see it. They wanted to be able to touch it. They wanted to be able to look at it. And so SQL made that too hard. That suddenly entire stakeholders who used to interact with the data now were unable to interact with the data. And so with Shiny, you can certainly create tools that make that data set suddenly accessible again, and make it, and even can provide it in Excel too. So these are all the same examples. So I mean, like another example is just like building upon some of other R's glue components. For most laymen's, working with Spark is basically impossible. Heck, even as an R programmer, I find working with Spark almost impossible. And so, now that we have tools in R that make working with Spark very simple, we can now we can automatically build user interfaces that also make Spark simple, because we have Shiny as this tool set that allows us to build these applications on top of our tools very simply. And so, summary, the reason we program is to take complex things and make them simpler. And so that's because, programming, like anything else, is about building interfaces. We build programming interfaces, we build graphical user interfaces, we build all sorts of different types of interfaces. And those interfaces, the purpose of them is to minimize complexity. My real thesis is a sort of last point, but the third point is there's sort of this tree of descending complexity where, as time goes on, we take functionality and tools we have and we create increasingly accessible interfaces for them so that they can be used by more and more people. And so my claim and my thesis that hopefully I was able to convince you of is that the primary success of Shiny is the fact that it's this next step in this tree of decreasing complexity in the tree of interactive data analysis. So, as R made things simpler than C and Tidyverse made things simpler than R, Shiny makes interactive data analysis simpler than just programming. So that's all I got.
I work with mainly database platforms like Datarama, Tableau, those types of things. I'm fairly new to R, that's why I came to this conference. Can you tell me about a use case where Shiny might be preferable to using something like Power BI or Tableau? Is it just cost benefits, I guess? Just curious.
I think there's a couple different trade-offs. And so, I think with something like Tableau, that provides you with sort of a graphical user interface for building those visualizations. And so, maybe it's a little bit easier to directly manipulate visualizations in a Tableau designer. Shiny is more about functionality. So, with Tableau, I think it's sort of like you import your fixed static data set and then you build a dashboard on top of it, and that can be very helpful. But with Shiny, it's more about R has this whole array of really amazing tools that have been developed for decades, whether it be in computational statistics, whether it be in machine learning, whether it be in something else. And so I feel like the real joy of Shiny is taking those R tools and making them accessible to a wider audience. Well, it's also nifty for building dashboards, and certainly that's where a lot of the value is. But I think it's about like sometimes it's harder to build a dashboard in Tableau because my data might be over in a REST API, or it might be in a Hive database, or it might be who knows where my data is. And so wherever it is, R will have the tools to make it available. I don't know if Tableau has all that functionality. Anybody else?
Do you at all know about bigger companies that have implemented Shiny? Because Tableau has a whole infrastructure that's tied to it. As far as if you buy into that product, usually the IT department's deciding to buy into that product. In turn, there's a whole technical support phone number. So in the situation where I'm at, there's thousands of Tableau users. What would happen if we
Well, so I mean, Shiny is technically supported by RStudio. It's there's a for-profit company behind it, and if you want to pay money for services, they exist. I think that like the real value add that Shiny offers is that I can take my existing R programming team and give them the ability to share all of their tools that they've developed with the laymen in my organization who don't necessarily have the ability to go into SQL databases or go into code and access things directly. And so, as far as the challenges of getting Shiny implemented in enterprise, I mean, there are some limitations, and part of that is that that's not where the abstractions really aren't. Like, that's not where the work is in the built-in abstractions. The built-in abstractions make the development really easy. They don't necessarily make the hosting and the running in enterprise easier. So that's less of where the value is added. If you want to make Shiny run in production, it's certainly possible. I saw Sean Locke at RStudioConf make a Shiny app run with 10,000 concurrent users, but like you as an organization or you as a programmer are going to have to explicitly put in the work to make a Shiny application work in production. So that's less of where the value add and where the abstractions are provided.
If I may comment, I mean also Shiny is a technology, while in the case of Tableau you have the technology Tableau and the company Tableau together. So eventually there will be a company who will come out and market this technology and build some product around it.
And certainly there have been. There's a company in Europe that sells Shiny enterprise tools, and like I said, running Shiny in enterprise is certainly possible. I don't want to discourage people from doing it. It's just like the abstractions built into Shiny where the work is made simple. That's in the development process. That's in the sort of taking the R tools and making them accessible to other users. The tool set for making those applications run in enterprise and available to your organization are a little